Hello, I welcome you to this wonderful and exciting video. Here we're looking at questions under accelerated linear motion, okay, which we explained in our previous videos. So today we're just going to talk about specifically just some revision questions so that the topic can be well understood. So we have this revision exercise and we'll be answering these questions. So you walk from Chisale to St. Francis, a distance of 60 kilometers in 50 minutes. Find the average speed, okay? So we're trying to find the average speed. So here's what we're going to do. So we're going to have solutions here. We're simply going to say solutions. Okay, so we want our solutions to be here. So the question simply wants us to find, said you walk from Charlotte Francis, you've been given a distance and you've been given, so this is distance, okay, and this is time, okay. So we know we can use speed, okay. Average speed is equal to average speed is equal to total distance over total time, okay. That is the average speed, okay. So total distance over total time. Now speed, we're told it's supposed to be measured in meters per second. So there are two ways that you can do this. So you're going to write your formula nicely, okay. Average speed, or speed average, is equal to total distance, okay. I'll just say TD over total time, okay. So when you look at here, the total distance is 60 kilometers, okay, 60 kilometers. So is it 60 or 6 kilometers? 6 kilometers. So you're going to say 6 kilometers over 50 minutes, okay, 50 minutes. Now remember, they want us to find the speed in what? Meters per second. So we can change the kilometer to meters, and this will give us 6,000 meters. Just multiplying that by 1,000, 6,000 meters over 50 minutes. That is 50. How do you convert a minute to seconds? You simply multiply by 60 there, okay. If you wanted to make your work easy here, you can try to cancel out what you can, okay, just to make your work easy. You can cancel the zero there, 6 there, 1, 6 there, into 6, 1, so you've got 100. And when you do 50 into 100, what do you get? You get that's 2, okay. You get 2 meters per second. You get 2 meters per second, okay. So that is what you have there, okay. So now somehow you can also just try to work it out from here. You have 6 kilometers over 50. You can go ahead and do 6 divided by 50, and here you are going to get 0.12 kilometer per minute, okay. And then you can have to convert this, but this will be more work. It's better you convert them as you're using the formula, just like that, okay. So what did I use here? I use this conversion. 1 kilometer is equal to 1,000 meters. And then for minutes, I said 1 minute is equal to 60 seconds. Okay, so this is the conversion, the converting system that I was using here, okay. And then a man rides on a bicycle. He accelerates from 8. So whenever you hear the word rest here, just know that your initial velocity is 0, okay, 0 meters per second. And then to this, so this becomes your final velocity. This is your time. What is his acceleration? Okay, so that was one question. That was question 1. We go to question 2. Find the acceleration. We say acceleration is equal to v minus u over t. Okay, so your final velocity, we said it's 8. Your initial is 0 because it's starting from rest. So this is going to be 8 meters per second minus initial is 0 meters per second over the time, which is 5 seconds, and this is going to be 8 meters per second over 5 seconds. And what you get here, 8 divided by 5, you get 1.6 meters per second. Now you have second and second here, that's why it becomes second squared, and these are the SI units for acceleration. Okay, so then we got a man drives a car at 50 kilometers per hour. This is actually the speed, or it could be velocity. He brakes. Okay, so when he brakes and then he stops, okay, so he's braking and then he's stopping. So when he is stopping, you know that your initial, your final velocity will go to 0 because he's stopping the car. Okay, so your final velocity here will go to 0 meters per second. Okay, 0 meters per second. Then your time is 3 seconds. Okay, the time is 3 seconds. Calculate the deceleration. Okay, so sorry, so this was the speed. So he's driving at this speed, so this would be our initial speed. Our initial speed. So that is question number 3. We are going to say question number 3, we're going to say we use the same formula for acceleration is equals to final velocity minus initial velocity, okay, over time. So now here we have, since the car is stopping, it was moving. This is initially it was moving at this speed and then it goes and stops. So now our job is just to convert this 54 kilometers per hour into meters per second. So we have your initial, which is 54 kilometers per hour. To convert it now, we want to convert this to meters per second. In other words, the kilometer, we convert it to meters and the hours to seconds. But I'll tell you a secret here. So you just divide this thing by 3.6. Sometimes in the exam you don't have time to convert all these. You can just divide it by 3.6. I'll explain where the 3.6 comes from, but just divide by 3.6. And what you get, 54 divided by 3.6, you get 15 meters per second. Okay, so when you want to convert kilometers per hour to meters per second, just divide it by 3.6. Okay, this comes from the fact that 1 hour is simply equal to 3,600 meters. Okay, 6,000 seconds. Then the kilometer here, remember, converting it to meters, you divide by 100, to 1,000. Okay, so you move 1 2 3, and that's how you land on 3.6. Okay, if you don't understand this, just memorize that for you to convert kilometers per hour to meters per second, just divide by 3.6. Okay, so now we have our our final velocity, remember the car is stopping, so it's 0. So your final is 0 meters per second minus your initial, which is 15 meters per second, over the time doesn't change, 3 seconds, and here you are going to have negative 15 meters per second out of 3. And what do you get? You have 5, negative 5 meters. So remember, seconds, there are seconds and seconds, you get 5 meters per second squared. Now this is what we call the deceleration, okay, or retardation, okay, it is called deceleration or retardation. When acceleration happens to be negative, this simply means that the car is actually slowing down, okay, it is slowing down. So it slows down till it does what? It stops, okay. So once the car starts to slow down, it's in what? Deceleration, or what we call retardation, and then it stops. So when the car stops, always know that your final velocity will be 0, okay. The final velocity, so that's why we use 0 as your final velocity, and then the initial is already given, and then you find your deceleration like that. Okay, so we go to question 4. A car starting from rest. Just the moment you see car starting from rest, you know your initial velocity is 0. Accelerates uniformly at this, so this is your acceleration. Okay, and this is the time in 3 seconds. Calculate the final velocity. This is a very simple question here. Question 4. So for question 4, you're simply going to say final velocity is equal to u plus at. Okay. Now basically it's just the same formula here, just changing the substitute formula to v. Okay, so your initial, we said it's 0 meters per second plus acceleration happens to be 5 meters per second squared. So you say 5 meters per second squared multiplied by the time. We're told in 3 seconds. Okay, so time is 3 seconds. So this will be 0, don't give us anything, 5 by 3, you get 15 meters per second, and you are good to go. Question 4, this was A, and there is question 4B. Calculate the total, or calculate the distance covered. Okay, the distance covered. There are two formulas that can be applied here. So for B, we can use distance, which is x is equal to ut plus half at squared. Okay, remember your initial velocity is still 0, so 0 times t, which is 3, then plus half a, your acceleration is what? Still 5, we're still on the same question, times your time is still 3. Okay, so you say 3 squared. These will give us a 0, you can forget about them. So half times 5 times 3 squared happens to be 9. Okay, so now this is going to be 5 by 9 multiplied, so 5 by 9, that's 45, divided by 2, you actually get 22.5 meters. Okay, and so you can calculate for this one. Go to question 5. A car accelerated uniformly from, so it says from, meaning that's why it's starting from. This is your initial velocity and this is your final velocity, and it traveled a distance of 50 meters during this. What was the acceleration? So here you notice what we are given. Question 5, we're given distance, okay, distance, under here we use x, so we're given a distance of 50 meters, and we are also given initial 10, final 20, initial 10, then final 20, then we're taught to find what are we finding? What was the acceleration of the car? Find the acceleration of the car. This is pretty much simple as well. We can use the formula. Distance is equal to v squared minus u squared over 2 times acceleration. Okay, and this is the same as acceleration is equal to x, acceleration is equal to v squared, okay, v squared minus u squared over 2 times the distance. So your final happens to be 20, so you're going to say 20 squared minus your initial 10 squared over 2 times 50. Now this will be 400 minus 100 over 100. And this will give us 300 over 100. You get 3 meters per second. Okay, we get 3 meters per second. Okay, that's our acceleration. The other question says, how long did the car take to travel this distance? How long did it take to actually travel this distance? Here, when you see how long, you're finding time. When it says how far, you're finding distance. So how long, you're finding time. How long now does it take? Okay, how long? So you're trying to find the time that it actually takes, okay? The time that it will take to cover this distance, okay? So here's what you're going to do. You need, so acceleration now is 3 meters per second squared. Now let's find time. So time is simply equal to v minus u over acceleration. So your final is 20 minus your initial, which is 10. Your acceleration is 3. You get 10 over 3. Your time will be what? 10 divided by 3. You get 3.3. 3.33 seconds. Okay, and you're good to go. So these are just revision questions, just to make sure that the topic was understood. Here the video is in the description. The link is in the description. You can watch the previous video to this video that I was just doing here.